Okay, in this video we're going to talk about how do I determine slope and what can I use it for. It's a lot to kind of unpack in this, and I'll talk fast, so please remember, pause, rewind, watch the video again. Slope is the rate of change. Now there's a lot of different ways we can look at this. If we are just looking at two coordinates, you might label those coordinates as x sub 1, y sub 1, and x sub 2, y sub 2. In which case you first take y sub 2 and you subtract y sub 1 and you make a fraction or like a ratio or division, kind of like the relationship ratio might, like a rate. X sub 2 minus y sub 1 or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You subtract these two and you end up with a rate, and that's your slope there. As long as x sub 2 does not equal y sub x sub 1. What that would do is you'd end up with an answer of 0 down here, and we can't divide by 0, which means you have what's called an undefined slope. And what this would actually look like if you graph these 2 points and drew a line connecting them, you'd end up with a vertical line. So in this case, the slope's considered undefined. It's one isolated case. Usually we won't really address that much, but just FYI. Say you're looking at a graph. The way I like to remember it is rise over run. You gotta stand up before you can run, right? So rise is how far up does it go, and then how far over does it go? Or sometimes that might be down and back, depending on how you're looking at it. Anyways, so keep in mind that those could be negative numbers. And finally, if you're looking at like a table, you could basically create coordinates from the table and do it this way using the formula. But I think delta y, with that triangle means delta means change in y over change in x. And you create those rates there. So that's what slope is. That's the 3 ways we're going to look at finding slope in this video. All right, so say I have coordinates 3, 0, and negative 11, negative 15. So I take my y coordinates, the second one minus the first one, so negative 15 minus 0, and the second x coordinate, negative 11 minus 3. That's going to equal negative 15 over negative 14, which would actually, because you have two negatives, it cancels out, and you end up with 15/14 would be your slope for these two, a line between these 2 points. Say I have a graph here, and this graph I'm using, I have a point down here that's at negative, that's right down here, and a point that's here. I could figure out the coordinates and do it this way, or I can actually just count rise over run. 1, 2, 3, 4, 1, 2. So it's up 4 over 2, which would be 4 halves, which can be reduced to just a slope of 2. So those are two positive slopes. Now I made a chart here, and if you're reading from like a table here, if you're reading from a table, you can basically look at, I said delta y over delta x, so change in y over change in x. You can look at my change in y goes from 7 to 5, so I'm minus 2, minus 2, minus 2. So that's the pattern there. So I put minus 2 as my numerator because that's what's doing. And the change in x is plus 3, plus 3, plus 3. So I put a 3 as my denominator here. So minus 2 over minus 3, which equals negative 2/3. So in this case, my slope's negative, which just means that instead of the graph increasing, it'll be a decreasing graph here. Now, sometimes you're going to be comparing two linear equations, and you'll say, okay, does the slope parallel? Meaning they're equal. So if you get it into y equals mx plus b form, or you figure out the slope, if the slopes are equal, you have two parallel lines. That would be if your slope was 1, or say it was even as 3/3. If you figured out the slope was 3 over 3, that's the same as 1. So those are all equal slopes. Perpendicular does not mean that it's necessarily, it's the opposite reciprocal. So there's two key things in here. You have to have the opposite, which means if your slope is negative, it needs to be positive to be perpendicular. But the reciprocal means you also will create a fraction over 1. So for example, in this one here, m over 1, so you do 1 over 1, you'd flip that, it'd still be 1 over 1, and you make it negative. So these would be perpendicular. And you can indicate that by writing this symbol here, and upside down t. Upside down capital T. Or if you had a slope of m is negative 3, your slope was negative 3, so then the opposite reciprocal would actually just be 1/3, would be a perpendicular line. Now, most lines, if you're not parallel or perpendicular, you'd be neither, and that just is not one of those. So if it doesn't fit perpendicular or parallel, then, for example, if the slope was 3/5 and the other slope was 3, then those would be neither parallel or perpendicular, which means there would be intersecting lines, but they just wouldn't intersect at a right angle. So finally, how would I use this? What would I use this for, right? Say you have a delivery service, you can create a graph, or you can figure out the rate of change in this delivery service. Now this delivery service is a constant rate of change, so you'd be dealing with what's a linear function. And when I look at this, I see a table, so I think of the change in y over change in x, right? Delta y over delta x. Again, you could make coordinates, you could graph it and figure out from the coordinates of the graph, or you can just figure it out straight from the table. 1 to 2 is a +1, 2 to 3 is +1, 3 to 4 is +1. So I'm doing +1 is my change in x, so I put a 1 here, and my change in y, or my charges, would be +7, +7, +7. So it's +7 every time, so it'd be 7 over 1. So my slope in this case would just be 7. I guess it'd be $7 per mile would end up being kind of my slope there, $7 per mile. And that is how I determine slope and what I can use it for.